Hello, my name is Daniel, and today we will be going through the AMC 10B of the year 2007. So let's get right into it. Problem 1. Isabella's house has 3 bedrooms. Each bedroom is 12 feet long, 10 feet wide, and 8 feet high. Isabella must paint the walls of all the bedrooms. Doorways and windows, which will not be painted, occupy 60 square feet in each bedroom. How many square feet of walls must be painted? So it has 3 bedrooms, and then bedroom is 12 feet long and 10 feet wide and 8 feet high, so it's 8 times 12 times 2, 24 plus 20. But then we have to do occupies 60 square feet minus 60, so this is 3 times 8 times 44 minus 60, which is 3 times 8 times 44 is 3352, so it's 292. This is 6. 3 times 9, 27. 3 times 2 is 8, 876, so it's E. And problem number 2, define the operation star by A star B is A plus B times B. What is 3 star 5 minus 5 star 3? So it's 3 star 5 is 8 times 5 minus 5 star 3 is 8 times 3. So 8 times 5 minus 8 times 3. This is 8 times 2, so 16. So it's E. Problem number 3. College student drove his compact car 120 miles home. For the weekend, averaged 30 miles per gallon. So 30 miles per gallon, this means that he used 4 gallons. On the return trip, the student drove his parents' SUV and averaged only 20 miles per gallon. So this means he used 6 gallons. What was the average gas mileage for the round trip? So the round trip means that it was 240 miles. And then this over 6 plus 4 gallons, so 10 gallons. This is 24 miles per gallon, so it's B. Problem number 4. The point O is the center of the circle circumscribed about a triangle ABC with BOC is 120 and AOB is 140. What is the degree measure of ABC? So BOC, if there's O in the middle, then BOC is 120 and AOB is 140. So ABC, what we want is this one right here. So to get this, we can see that this is 316 minus 140 minus 120. So that is 100, and so this angle is half of this angle, which means that this must be 50 degrees. So it's 50. It's D. Problem number 5. In a certain land, all arrows are breaths, all crops are breaths, all drams are arrows, and all crops are drams. So all arrows are breaths, all crops are breaths, all drams are arrows, and all crops are drams. Oh, so fitting this. So crops. So fitting these two together, we get crops and drams, and then feeding this together, this is drams and arrows, and we put in this here, and then we get breaths, and breaths are the biggest. Which of the following statements is implied by these facts? All drams are breaths, yes, and our crops, no, not crops. So A is wrong. All breaths are crops and are drams, no. There's this part, so it's wrong. All arrows are crops and are drams, no, it's wrong. All crops are arrows and are breaths, yes. D is correct. Problem 6. 2007 AMC 10 will be scored by awarding 6 points for each correct response, 0 points for each incorrect response, and 1.5 points for each problem left unanswered. After looking over the 25 problems, Sarah has decided to attempt the first 22 and leave only the last 3 unanswered. This means that there's a 4.5 points for unanswered, and attempting the first 22, she wants to score 100 points, so she must get additional 95.5. So So how many of the first 22 problems must you solve correctly? So this is 95.5 points, and there are 6 points for each correct response. So it has to be at least 95. So 6n has to be greater than 95.5. So n is 16. If n 16, then it's 96. Yes, so it's plausible. So n is 16. So at least 16. At least 100 points. This is D. And problem 7. All sides of the convex pentagon ABCDE are of equal lengths, and B is 90 degrees. So for this to be true, there's only one way, which is that there's a square like this, and then there's an equilateral triangle like that. So this will be A, this will be B. The pentagon would be like this, and A and B equals 90 degrees, as seen here. What's the degree measure of E? So it's A, B, C, D, E. So the degree measure of E is, if we put this here, then it's 90 degrees plus 60 degrees. 90 plus 60 equals 150, so it's 150, it's E. Problem 8. On the trip home from the meeting where this AMC plan was constructed, the contest chair noted that his airport parking receipt had digits of the form B, B, C, A, C, where A, B, and C are different. A is the least, B is the second least, and C is the greatest, and they are all between 0 and 9. B was the average of A and C. So first, let's see from A's point of view. A could have been 0, right? And then since B had to be an integer, so C could have been 2, 4, 6, 8, and so there are 4 possible responses. So there are 4 possible numbers. If A is 1, then it's 1, 3, 5, 7, 9. No, it's not 1. 1's not possible because they can't be the same. So it's 3, 5, 7, 9. So it's 4. If A is 2, then it can't be 2, right? So it's 4, 6, 8. So it's 3. And if A is 3, then it's 3, 5, 7, 5, 7, 9, which means that it's 3 also. And if A is 4, then we have 6, 8, so it's 2. If A is 5, there's also 7 and 9, which is 2. A is 6, this means that C is only 8, so there's 1. A is 7, this means that C is only 9, there's only 1. So 4, 4, 3, 3, 2, 2, 1, 1, if you add all these, then these will add up to 20. So it's D. Problem 9. A cryptographic code is designed as follows. The first time a letter appears in a given message, it is replaced by the letter that's 1 place to the right. And the second time, it's 1 plus 2 places to the right, and 1 plus 2 plus 3 places to the right. And so what letter will replace the last letter S in the message? Lee Sis is a Mississippi Miss Chris. So first we've got to count the S's. There's, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this last letter S, this is 1 plus 2 plus all the way until up to 12 places. This is 12 times 13 over 2. This is 6 times 13. This is 78. 78 places. But then, if we divide 78 by 26, then this is 3. So this is 3 complete rotations in the alphabet. So it means that it's just going to come back onto itself, because it starts from S, and then there's 26, 26, and then there's last 26, so it's just come back to S. So it's S, so it's D. Number 10, 2 points B and C are in a plane. Let S be the set of all points A in the plane for which triangle ABC has area 1. So if 2 points B and C are in a plane, let me draw this. They're in a plane. They're very, very safe. And then they're in this great plane. I'm kidding. Let S be in the set of all points A, so there's B and there's C, right? But then triangle ABC has area 1, so if BC has length x, then this has to be 2 over x, right? And or it could be at the bottom 2 over x. So S could be all the points in this line or in this line, because the height would be the same, and that will make the area 1. So this is 2 parallel lines, so it's A. Problem 11. A circle passes through the 3 vertices of an isosceles triangle that has 2 sides of length 3 and a base of length 2. What is the area of the circle? 3 vertices. So there's a 3, 3, and 2 side. What is the area of the circle? So if we draw a circle like this, yes, not bad. Then if we want to get the area of the circle, then so it's an isosceles triangle, right? So this is 3, this is 3, and if we cut it in half, this will be 1, and if if this is the center, this will be R. This will also be R. If it's 3, there's 1, there's 2 root 2. This is 2 root 2 minus R, so it's 2 root 2. So we have to use the Pythagorean theorem here. So in this triangle, this is a right triangle, so we have to use the Pythagorean theorem. So r squared equals r squared minus 4 root 2 pi, no, what, r squared minus 4 root 2 r plus 8 plus 1. So r squared, they erase. 4 root 2 r equals 9, and r equals 9 over 4 root 2. So the area of the circle, this would be 9 over 4 root 2. So the area is pi r squared. This is pi times 9 squared is 81. 4 root 2 squared is 32. 32, so it's 81 over 32 pi, which is C. Problem number 12. Thomas' age is t years, which is also the sum of the ages of his 3 children. His age n years ago was twice the sum of their ages then. What is t over n? So if Thomas is t, the sum of the ages of his 3 children, a plus b plus c. T equals a plus b plus c. His age n years ago, t minus n. This is twice the sum of their ages then. A minus n, b minus n, c minus n. So this is 2a plus b plus c minus 3n here. T equals 2a plus b plus c minus 6n plus n. Since ABC is t, let's put that here. There's 2t minus 5n. T is 2t minus 5n, so 5n equals t. T is 5n, so t over n equals 5n over n, which is 5. So it's 5, it's D. 13. 2 circles of radius 2 are centered at 2, 0 and a 0, 2. What is the area of the intersection of the interiors of the 2 circles? So we want this section here, right? So what we have to do is we can get this whole square, and the square has 2 side lengths, right? So square, this is 4, and then we can get 2 of these quarter circles. 2 times quarter circle, so it's 1/4, times pi r squared, so it's pi times 4. This is 2 pi, so 2 pi minus 4, that's this area. So 2 pi minus 4, this is, if you take out the 2 times pi minus 2, so it's D. Problem 14. Some boys and girls are having a car wash to raise money for a class trip to China. Wow. Initially, 40% of the group are girls. Shortly thereafter, 2 girls leave and 2 boys arrived, and 30% of the group are girls. So that means 10%. That means 10% was 2 people. 100% is 20 people. And so, initially, it's 40% are girls, right? So it's 0.4 times 20 people. This is 8, so 8 people were girls initially. It's C. Problem 15. The angles of quadrilateral ABCD satisfy A equals 2, B equals 3, C equals 4D. So if there's a quadrilateral, I don't know how it's shaped. I'll just do anything. If it's A, B, C, D, then A is 2B, right? So B is A over 2, C is the A over 3, D is A over 4. So the degree measures, they will have to sum to 360. 360 equals A plus A over 2 plus A over 3 plus A over 4. So if you multiply by 12, then 360 times 12 equals 12A plus 6A plus 4A plus 3A, right? And this is 144 times 3, 12, 13, 432, 4,320. This is, I'll erase this, 12 plus 6 plus 4 plus 3, 25A. So rounded to the nearest whole number, A equals 4,320 over 25. This is multiplied by, no, if we take the 5 out of here, then 5, and then the numerator becomes 864. This is 1728 over 10, so it's 172.8, and it's to the nearest whole number, so it's 173. 173, it's D. Problem number 16. Teacher gave a test to a class in which 10% of the students are juniors and 90% are seniors. The average score on the test was 84. The juniors all received the same score, and the average score of the seniors was 83. What score did the juniors receive on the test? So here, let's say there are 10 students in total. So 1 is a junior, 9 are seniors, and the total points are, the average is 84, so total is 840. Seniors, they've got 83 multiplied by 9, which is 747. And then so if we subtract the seniors from the total, then the junior score comes out 840 minus 747, which is 93, it's 93. So the juniors receive 93 on the test. It's C. Problem 17. Point P is inside equilateral triangle ABC. Q, R, S are the feet of the perpendiculars from P to AB, BC, and CA respectively. PQ is 1, 2, 3. So if P is here, then this will be 1, 2, 3. So A, B, C, Q, R, S. So in this one, if a side length is x, then the total area, this is root 3 over 4x squared, and it's also, if you divide like this is x and this is also x, and these are perpendicular, so this is x times 1 plus 3 plus 2 over 2. This is 3x, and so root 3 over 4x squared equals 3x. Root 3 over 4x equals 3. X equals 4 root 3. So what is AB? So AB is x, and so it's 4 root 3. The answer is D. Problem 18, circle of radius 1 is surrounded by 4 circles of radius r as shown. What is r? So from this we can say that this much is r, and this much is also r, but this much, this is 1 plus r, this is 1 plus r, but then it's 90 degrees and it's 45 degrees. So 1 plus r equals r root 2. So 1 equals r times root 2 minus 1. R equals 1 over root 2 minus 1, which equals root 2 plus 1. So what is r? R is root 2 plus 1, so it's B. Problem 19. The wheel is spun twice and the randomly determined numbers opposite the pointer are recorded. The first number is divided by 4 and the second number is divided by 5, and so there's a remainder designating a column and a row. What's the probability that the pair of numbers designates a shaded square? So for this one, if there's so let's just put out the possibilities. 1, 2, 3, 6, 7, 9. And if it's divided by 4, then it's 1, 2, 3 would be the remainder, and it will be 2, 3, and 1. And if it's divided by 5, then the remainders would be 1, 2, 3, 1, 2, 4. So for the column, these are the columns, right? But for the columns, they would be 1, 2, 3, 2, 3, 1. So that means they would all be evenly spaced out. So from here, it's 1/2. No. So what I mean is, from here there is an equal chance of everything. Equal chance of shaded or unshaded. And for the rows, 1, 2, 3, 4. So there's 1, 2, 3, 1, 2, 4, which may seem asymmetrical, but if you see there's one, so there's one, so the one with two shaded is this is 1 and 3, right? So there's 2 1s and 1 3. There's 3 of them, and if there's one shaded, it's 2 and 4, right? So it's 2, 2, 4. So there's 3 of them. So this also has equal chance. So this means that collectively, it has the same chance of being shaded as same as the chance of being unshaded. So the chance of being shaded, the probability of being shaded, is the same as the probability of being unshaded. So this is all 1/2. Therefore, the answer is C. Problem 20. A set of 25 square blocks is arranged into a 5 by 5 square. How many different combinations of 3 blocks can be selected from that set so that no 2 are in the same row or column? So there are 25 square blocks. So how many different combinations of 3 blocks, right? But then if you select one, so the first one you have 25 choices. You can select any one of these blocks. Like let's say that you selected this one, then no two can be in the same row or column, right? So automatically these are all removed from your choices. And so if you exclude these ones, so then it would be like this is up here, this is here, and this comes down here. So it becomes a 4x4 square now. So now there are 16 choices. You have 16 choices now. Same thing, let's say that you pick this one, and so all these are unable, so you can't pick any of these. So these are just all out. So are these. And so you have 9 choices left. So that's your final 9 choices. But here's something you have to be careful about. You can pick so for this situation we have been considering the order, but then this one it just said the combinations, not the permutations, so we have to make this into a not considering order. So for that to happen, we need to divide this whole thing by 3 factorial, because see, like if you had this much and you picked it in this order, then it's the same as if you picked it in this order, right? And you have 3 factorial different ways that you can choose to tweak the what goes first, what goes next. And so that's why we divide by 3 factorial. And so if you make this is 3 factorial 6, and 25 times 16 times 9. This is 25 times 8 times 3. This is 25 times 24. This is 100 times 6. This is 600. So it's C. Problem 21. Right triangle ABC has AB is 3, BC is 4, and AC is 5. Square XYZW is inscribed in ABC with X and Y on AC, W on AB, and Z on BC. What is the side length of the square? Here is 5, 3, 4. But then the square is inscribed in there, so it's like this. We need to make this X. Let's say this is X, the side is X, and then this would be this, and then this side would be 3 over 4x. This side would be 4 over 3x, and then this whole side is 5, right? So it would be 5 equals 4 over 3x plus 3 over 4x. This means that it's 4 over 3x, yeah, x times 4 over 3 plus 1 plus 3 over 4. This is x times, the number is 12, 16 plus 12 plus 9. This is x times 20, 37. 37 over 12. So this is 5. X is 37 under 5 times 12. This is 60 over 37. So 60 over 37 is B. Problem 22. A player chooses one of the numbers 1 through 4. After the choice has been made, 2 regular 4-sided tetrahedral dice are rolled with the sides of the dice number 1 through 4. If the number chosen appears on the bottom of exactly one die after it has been rolled, then the player wins $1. If the number chosen appears on the bottom of both of the dice, then the player wins $2. If the number chosen does not appear on the bottom of either of the dice, the player loses $1. So you can choose one number, and for the 4-sided dice to be in that one of those 4 numbers, then it's a 1 out of 4 chance, right? Yeah, you know what I'm talking about. So if it's on both, then it's 1/4 times 1/4. This is 1 over 16 and 1. This is 1 over 4 times 1 over 3, no, times 3 over 4, and then since the order can be flipped, this is 2 times 2, so it's 6 over 16. And if both are fail, none. Then it's 3 over 4 times 3 over 4. This is 9 over 16. So 16 over 1, this times 2 because you win $2. This times 1 because you win $1. This times minus 1 because you lose $1. And if you add all these together, this is all the denominators are 16. This is 2. This is 6. This is minus 9. This is minus 1 over 16, right? So it's minus 1 over 16, so it's B. It's problem 22. Problem 23. A pyramid with a square base is cut by a plane that's parallel to its base and 2 units from the base. The surface area of the smaller pyramid that is cut from the top is half of the surface area of the original pyramid. What is the altitude of the original pyramid? The surface area of the smaller pyramid. So there's a smaller pyramid. That's 2 units above. Like this, and this. Just like that. So it's 2 units from the base. So the length from here to here, this would be 2 units. And let's say that this is h. So if this is 2 and this is h, the altitude of the original pyramid, so what we want is 2 plus h. And so the surface area is half the surface area, so the surface area of the smaller pyramid is half the surface area of the original pyramid, right? So the ratio of length squared is always the ratio of area, right? But the ratio of length is h to h plus 2, right? So the smaller pyramid to the original pyramid, this is h to h plus 2. And this squared equals ratio of area, which is, it says it's half, so it's 1 to 2. So if you just put a square root on everything, then h to h plus 2 equals 1 to root 2. So h plus 2 equals root 2h. 2 equals h times root 2 minus 1. H equals 2 over root 2 minus 1, which equals 2 over root 2 plus 1. So what we want is h plus 2, right? H plus 2 is 2 root 2 plus 2 plus 2 is 2 root 2 plus 4, which is E. So problem 23 is E. Problem 24, let n denote the smallest positive integer that is divisible by both 4 and 9, whose base 10 representation consists of only 4s and 9s with at least one of each. What are the last 4 digits of n? So since it has to be divisible by both 4 and 9, first for it to be divisible by 4, then the last 2 digits have to be divisible by 4. So the only way that this can happen is if the last digits are 4 and 4. So this doesn't work. And it has to be divisible by 9, so it needs 9 4s. So there would have to be like 9 of these standing here. Yeah, so this, but then we also need at least one of each, so we need at least 1 9, right? But then it has to be the smallest positive integer, right? So 9 keeps moving backward until it reaches the endpoint. So the furthest back that 9 can go, it's right up to this point. Because if 9 goes any further back, then it won't be divisible by 4, right? So the last 4 digits are 4, 9, 4, 4, so it's C. The last problem, problem 25, how many pairs of positive integers a, b are there such that a and b have no common factors greater than 1, and a over b plus 14b over 9a is an integer. So for this one, let's say that a over b equals x. So if that happens, then we can say that a a over b equals x. So that would mean that it's x plus 14 over 9x. So this is equal to an integer n. So if we multiply by 9x on both sides, 9x squared plus 14 equals 9nx. So 9x squared plus 9 minus 9nx plus 14 equals 0. So, and it's an integer, that means that x is 18. 18 would be the denominator, and it would be 9n plus or minus root 81 n square minus 9 times 14 times 4. So what would happen is that this would become n over 2 plus minus, and then this we can pull out the 3, 18, and then 3 root 9n squared minus 14 times 4 is 56. So it's out of 6. And then for this to be a rational number, a rational number, then it turns out that root 9n minus 56 would also have to be a rational number. So that means that if this is k, x equals this much. So if we move this up, root 9n minus 56 is the rational number k. So 9n squared minus 56 equals k squared, right? Because you squared both. So 9n squared minus k squared equals 56. So it's 3n minus so it's 3n plus k, 3n minus k equals 56. And then 3n plus k, 3n minus k equals 56. So it has to be 56 and 1, 2 and 2 and 28, 4 and 7, 14, and 7 and 8. So this would be 6n equals 57, 6n equals 30, 6n equals 18, and 6n equals 15. These two don't work, so 6n equals 30. This means that n must be equal to 5. This means that n must be equal to 3. So here the possible numbers of x could be if n is 5, then this could be a plus or a minus. If n is 3, then this could be a plus or a minus. That means there's this 4 total pairs. So the answer is 4. So it's A. Thank you for watching.